So first thing we have to do for this one is to put it in standard form. All these conics, except for circles in standard form, have a 1 here. So to force that guy to be a 1, I've divided every single piece by 16. So I'm going to get x squared minus, this reduces to y squared over 4. Now it equals 1, just like I planned. Now here, the center, because there's nothing being added or subtracted to the x or the y, your center is just 0, 0, which is very, very nice. And if we try to figure out how much right and left we go, there's nothing underneath the x, but there's an invisible 1 there. So I'm going to go right and left the square root of 1, which is just 1, and I'll plot that here and here, so 1 from the center. And for hyperbolas, the vertices, those are my vertices. Now note it's not the bigger one. For ellipses, the bigger one would dominate for the vertices, but for hyperbolas, it's the positive one. Usually the one that comes first is positive. So these guys are my vertices there and there, and I can read those right off the graph, -1, 0, and +1, 0. So I've got my center, my vertices. If I wanted to figure out the rest of the graph, I know I go up and down. Because it's underneath the y, that controls the up and down. Square root of 4 is 2. So up 2 from the center, down 2 from the center. These aren't really even co-vertices for hyperbolas. They're just points that are going to help us guide our graph. I know it's a hyperbola because there's a minus in the middle. And so instead of connecting the dots as if it were an ellipse, I would draw a box instead and draw my diagonals exploding out the sides of the box. And because the x is first, or positive, it opens right and left like the x-axis. So if they want me to graph it, that's what it looks like. And they want the foci. Now for foci, hyperbolas, as strange as they are, they get a normal Pythagorean theorem, c squared equals a squared plus b squared. So it's 1 plus 4. You do the opposite of what it looks like there. So c squared is going to be 1 plus 4. So c is going to be the square root of 5. And when we graph, that's about a little bit more than 2, a little bit more than the square root of 4. So from the center, 1, 2, a little bit more, 1, 2, and a little bit more. These are my foci. And foci for both hyperbola and ellipses are always on the same axis as the vertices, so here, right and left. And when you write them, you always start with your center. My center was 0, 0. Because I went right and left, I'm going to tack on plus or minus root 5 to the x's. Right and left is x direction. So these are my foci. Of course, it doesn't. The 0 is not really doing anything there, so that's plus or minus root 5, comma 0, and those are your foci. So we have center 0, 0, vertices -1, 0, 1, 0, and foci plus or minus root 5, 0. And that should do it.